Okay, so our topic today is going to have to do with limits eventually. We're just going to practice doing like the math that's involved with the limit so that Tuesday when we're doing those limits notes, they're not so overwhelming. So the review day is called like complex algebra and domain and range. We're going to review various algebraic operations that can be used to simplify expressions for completing a variety of problems. These are the types of problems that you'll see within limits and other stuff that we do this year. So the first thing we're going to review is how to simplify by using a conjugate. So when you see this word, I want you to attach this word to a square root symbol. If you see a problem that has something added to a square root, something subtracted from a square root, or a square root plus something, a square root minus something, a square root gives you an option as a conjugate to simplify. You might see this, or you might remember this in the context of rationalizing. And I have some good news for you, which is that I will never force you to rationalize in here. So that's good. You won't have to rationalize. It's just a matter of getting your expression to the format that you need, which could be the square root on the top and it could be the square root on the bottom. So it could be either way in here. So this has a square root, which tells me I'm going to use the conjugate. So a conjugate works like this. If you have two things added or subtracted together with a square root in there, then the conjugate is the same expression, but with the opposite sign. So if your expression had an a plus b, your conjugate would be a minus b. And if your expression was a minus b, it would be a plus b, of course, with a square root in there. So since I see a square root here, and I've got a minus sign in the middle, my conjugate that I'm going to multiply by is 7 plus square root x plus 2. And then I can multiply by that on the top. And then I have to multiply by the same thing on the bottom, because when you multiply a fraction by a value, it's got to be the same thing top and bottom. Otherwise, it changes the value of the fraction. Okay, then I want you to simplify by grouping this in parentheses and multiplying stuff out. Question.
Well, why do you not change the sign inside the radical?
Good question. So I don't want to change the sign in the radical because I want this part right here to be the same. It's just that I want to change. So you won't change the sign in the radical. It's a good question. Okay, so now I'm going to multiply. On the top, I have to FOIL. So I've got two things here and two things here. The plus sign and the minus sign here in the middle breaks it apart into two pieces. So I do 7 times 7 first, which gives me 49. Okay, and then I'll write this next step really, really small. When I do 7 times radical, I got plus 7 radical x plus 2. And then when I go to distribute the next thing, the negative sign in there is going to be minus 7 radical x plus 2. Now then if I do last times last, it's a negative times a positive, so it'll stay negative, but a square root of something times itself, it just cancels out the square root. So it's going to be minus x plus 2. Okay, so I wrote pretty small there on purpose because every single time you do this, this part right here, oh, that won't change color. That middle part is going to drop out every time. And you might be like, well, why? Why would that always drop out? Because I picked the exact same opposite expression. So it'll end up with a positive and a negative of the same thing, and those will always drop out. So it is okay with me if you skip that step because I know it happens every time. Okay, so if you want to skip that step and just do first times first and last times last, because you realize those middle terms drop out, that's okay. On the bottom, I want you to leave the parentheses on the bottom and not distribute that yet. I'll explain why here in a second. Just kind of like multiplying the top out right now. And now when I bring my next line down to simplify, I've got 49. And if I distribute the negative here, it'll be minus x minus 2 over 3x times 7 plus radical x plus 2. And then now I can combine the 49 and the 2 will be 47 minus x over 3x parentheses 7 plus radical x plus 2. Now, on the bottom, I don't want you to distribute because sometimes what will happen is the numerator will simplify so far down that it will cancel with one of these things. So like maybe this 3x might have something that would cancel up there. I can't cancel it now because that x is subtracted, like 47 minus x. And so I can't cancel the x's now, but sometimes you will get something up there that like reduces way down and it does cancel. So that's why we don't multiply the denominator out just where the square root was. And as of right now, I know this looks unrationalized, but we're going to be okay with unrationalized. We're just going to leave it like that. In the context of limits, like that's how we would leave the expression, and then we would finish our limit problem. So multiply by conjugate is multiply by the opposite sign. The radicals in the middle drop out. And then the square root times square root drops out the square root symbols, and your numerator should no longer have any square roots. And we're just going to practice that a couple of times today. We've got a worksheet to practice that on. Questions on the first one? All right, second problem is complex fractions, and this will come up a lot, like actual almost every problem probably. Oh, I won't let me change. Anyway, okay, so complex fraction is if you have like one big fraction bar, but then either within the numerator or the denominator, you have more fractions. So it's the fractions inside of other fractions. And what I want you to do with that is get a common denominator. And then do a keep, change, flip. But you might remember those words from ages ago. Okay, so I look for the spot where I can get a common denominator. My overall denominator just has a 3x. So that right there, I'm just going to leave alone. But in the top of that big fraction, I've got two fractions. And between those two fractions, I can get a common denominator. And I'm going to try to do this slow, but I try to do my denominators like without showing 10,000 steps, try to be like efficient with it. So if you can try to follow me on this. So like, okay, 3x stays the same. My common denominator has to have a 4 and it has to have an x plus 1. So up here, I'm going to have a 4x plus 1 as the common denominator. Okay, then what I have to multiply by up here is just like when you're doing like basic fractions, I have to multiply by what's missing. So this has a 4 in it. This fraction needs to be multiplied by x plus 1 on top and bottom in order to have that common denominator. Now it has 4x plus 1. And this fraction has to be multiplied by 4 on top and bottom in order to have the common denominator, and now it's got both. So that step I usually kind of do in my head or like write out just small on the side. And what I fill in here is x plus 1 times 1 minus 2 times 4. I just do the numerators across because they have the same denominator. And then kind of simplifying that numerator, I get x plus 1 minus 8. My common denominator was 4 times x plus 1, and then all of that is still over 3x. So common denominator step, wherever the complex fractions are that are within the other fraction, you're working on a common denominator of that. Okay, then keep, change, flip. So I'm looking at, this is my big fraction bar right here. That's the one that I'm going to change. And then I'll flip the denominator. So I keep this. This is going to change to a multiply. And then this 3x is going to flip to 1 over 3x. So on the top, I'm going to try to do 2 steps in one here. I'm going to do x plus 1 minus 7. That reduces to x minus 7. So this numerator is just going to be times 1. If you're multiplying by fractions, you multiply straight across. So it's just going to be x minus 7 times 1. And then on the bottom, it's up to you. Like this is a simple one. You could distribute if you want. I'm actually going to choose not to distribute just in case there's something that cancels out later, it's better to have things in factored form. So all I would do here is multiply the 3x and the 4. That would become 12x times x plus 1. It is okay though, if you want to distribute, you could distribute in the 4 and then also distribute in the 3x. But algebraically, it's just these two things have to multiply together because then they would both get distributed into the x plus 1. Now in this case, nothing cancels, but like there's always potential for something more to cancel. Just that minus sign in there means I can't cancel these x's out because it's x minus 7, not just x. Okay, you with me so far? Kind of a lot to jump into. Okay, so next one is simplify with complex fraction and a conjugate, both. Okay, so this one is gonna have both. I encourage you to write kind of small here because there's gonna be some long fractions. We're gonna do the common denominator, keep, change, flip, but then we're also gonna do a conjugate because there's a split root. So there will be a lot of math in this one. Okay. All right, so to start out with, I see that this is a big fraction bar. So I'm gonna work within the numerator. Leave that x on the bottom for now. But within the numerator, I'm going to figure out my common denominator would have both this and this. So it's going to be radical x and radical x plus 2. And I kind of go back to my original expression here, and my first fraction has the radical x, but for my common denominator, I would have to multiply by radical x plus 2 on top and bottom. And that gives me the denominator that I need. In this fraction, I've got the radical x plus 2, but I have to multiply by radical x top and bottom. So now what I have in the numerator here is 3 times radical x plus 2 minus 3 times radical x. So I multiply those two together minus those two. I can combine these though, because these are different radicals, right? Radicals work just like x's. Like if you got an x and an x squared, you can't combine them. So these don't combine. So that's just leave it like it is. But now I'm going to do a keep, change, flip. Here's my big fraction bar. So that's the part that's going to change to a multiply. And x is going to flip to 1 over x.
You're not combined to root x.
You could, yep. So these with square roots, you can multiply them. So you can distribute this through if you want and call it square root x squared plus 2x. That's totally okay. I tend to not multiply things out, and you'll see that as a pattern of ours. Like in calculus, you're not necessarily required to simplify in a certain way. I know you're used to having teachers be like, "Oh, simplify it to this process or whatever." But we do so much of this like within our other stuff. It's just kind of whatever makes more sense to you. Okay. Because these are not going to be our final answers. This is just going to be like our work within problems. Okay, so with that in mind, then this one doesn't have a square root, so it wouldn't distribute into there anyway, but I'm just going to leave this all on the bottom as like stuff multiplied together. But you could distribute that square root and that'd be okay. You can't distribute the x out front though. Okay, then numerator is like this whole numerator times 1. Okay, so we're not done with our problem per se, but we're done with the common denominator part. Does that look okay to you? Everyone, like, that makes sense? Okay. All right, so I didn't write small enough, so let me rewrite this over here. So our next step is also to be able to do a conjugate. So to do a conjugate means you've got square roots or something added or subtracted from the square root. So like these two square roots are subtracted. So the conjugate would be the same thing, but a plus sign in the middle. So I'm going to identify my conjugate as being 3 radical x plus 2 plus 3 radical x. And then now this is getting, oh, I did something wrong. Did anyone see it? Sorry, I didn't catch it until just now. I was just like thinking and not paying attention. What I do? Okay, excellent. Actually, this part is okay. The plus is okay. That sign's gonna be the same. It's this sign right here that I was changing. Anyone else see the mistake I made? The denominator, thank you. It's Friday. I was daydreaming for a second about the weekend. Sorry. We don't match the denominator over here. When you're multiplying to get a common denominator, you multiply by the same thing over itself. Sorry. So sorry about that. 3 radical x plus 2. Sorry, guys. Plus 3 radical x. So same thing, top and bottom here. When you identify your conjugate, you're doing the same thing, top and bottom. Okay, then on the top, I'm going to try to be efficient with my work. I know you're used to teachers being like, show every step, and I still want you to show your steps. But sometimes at this level, there's steps that I'm okay with you skipping, and this is one of them. So like, I'm just going to do first times first is going to be 9, and then the square roots cancel out. So 9, and then just times x plus 2, because the square roots cancel. Here's the step that you can skip. So when I do outer and inner, I know that those two are going to be a positive something and a negative something that are identical, and they will drop out. So because it's a conjugate, I can skip that step. And then I'm going to go back to then doing last times last, and I'll get minus 9 times just x, because that square root will cancel. Now, our denominator is going to be absolute chaos, and we're just going to ignore the fact that it's absolute chaos and just write it all down. So it's x for x plus 2, parenthesis 3 radical x plus 2 plus 3 radical x. And you do not have to bother trying to simplify that out, because in the context with which we do stuff, a lot of times something will cancel out on the top and bottom. And I don't want to have distributed it in there, then just have to factor it back out to cancel. Okay, so I'm going to distribute now. This would be 9x plus 18. My 9x's are going to cancel. So I'll just end up with only 18 on top over chaos on the bottom. And then at that point, for now, we're going to say this is our answer. Because there's nothing else we could do to simplify as far as fractions or square roots, or if there was anything to cancel on top and bottom, which there isn't. Okay, questions on those 3 problems. So that's like common denominator and conjugate, which are going to be strategies that we're going to use for limits when we come back on Tuesday. All right, the second part of what we're doing today is just reviewing domain and range. Because we do a lot of square root stuff. Well, we kind of do a lot of everything, I guess. So domain and range, your domain are listing out all of the x values that exist on a function, and range is listing all of the y values that exist on a function. I'm going to repeat this to you a lot this year. So for domain, you're going to look for, this is a fraction, a square root, or a logarithm. I'm going to say that a lot. Be like, is there a fraction, a square root, or a logarithm? Fraction, a square root, or a logarithm. When you're doing domain, your answer is almost always all real numbers, unless you have one of these 3 things. So those are the 3 like exceptions or like cases that we have to look at to figure out what the restriction is on our x value. So if you have a fraction, you have to make sure the denominator is not 0. If you have a square root, you have to make sure you're not square rooting a negative. And if you have a logarithm, you have to make sure that the logarithm isn't of a negative number. You can't do an ln or a logarithm of something negative. Remember, we talked about that graph a lot this week. Logarithms don't exist over here for negative x values, only for positive x values. And then for range, you're going to just kind of have to use your knowledge of like shifting and functions like your knowledge of what the domain is to figure out the range. Range does not have like a special formula to it aside from just knowing your. Okay, so examples, find the domain. Okay, so I look for fraction, square root, logarithm. Fraction, square root, logarithm. This one's a fraction. So because it's a fraction, I can't divide by 0. So I take the denominator and I get 7/6. That's the one number that will make this not work. So my domain could be written like this: real numbers not equal to 7/6. Or you could say x not equal to 7/6. Or you could say negative infinity to negative 7/6 union 7/6 to positive infinity. So that one was a fraction. We had to keep the fraction from being divided by 0. So this would be your domain. Any of those three would be good. Any questions on that one? Okay. All right, let's look at the next one. Oh, we went straight to 2 hard ones in a row. Okay. It's okay. We're gonna jump right into a hard one of square root. Okay. So for square root, again, you're gonna look for a fraction, square root, or logarithm. Fraction, square root, logarithm. This one has a square root. If you have a square root, you can't divide by a negative. No dividing by negative. So that means whatever's inside here, you have to put greater than or equal to 0 to give you your domain. Okay, when I said like, ooh, we jump right into a hard one, the quadratic makes this tough. You are not allowed to add 9 and square root because you can't square root across an inequality. If this had been an equal sign, like you can square it across an equal sign, but you can't square it across an inequality. So if you've got this symbol in an expression, you have to solve it a little bit differently. So I'm going to solve by factoring on this side. And then you might remember this from last year. You're going to make yourself a little number line and put the zeros of the function on the number line. And because this is an equal to, we're going to close in these circles. And then we're going to test numbers to figure out what makes this a true statement. Where does this end up being actually a positive value? So over here, my test value on this interval might be like -5. And you don't have to show work for this. You can do this in your head. That's fine. If I plug in -5 here, -5 plus 3 is something negative. -5 minus 3 would be something negative. And a negative times a negative is a positive. So that part does work for the greater than or equal to 0. So this part is going to be a part of my solution. Then I'm going to do a test value here. I think 0 is probably the easiest. So if I plug in 0, I'm going to get +3 times -3, which would be a negative number, which means this is not a part of my solution. And then I'm going to plug something in over here, like say +5. I plug in +5. Okay, so we plug in +5, we're going to get 8 and 2. 8 times 2 is positive, so this will also be a part of the solution. And so your domain for this would be, you could do -infinity to -3, closed bracket, because at -3, you get exactly 0. And you are allowed to take the square root of 0. If I plug -3 in here, I'll get square root of 0, and that's fine. You just can't square root a negative. Yes, question?
Just a greater than sign. So
Nope. Good question. If this was just a greater than up here instead of an equal to, you'd have an open circle there. Yep, good question. Yeah, you could also plug in, like your test numbers that you took here, you could also plug in up there to see how that works. Yep, definitely. I'd like to plug into the factors, but the other one works also. Another way you could write this would be x less than or equal to -3, or x greater than or equal to +3. That was kind of a hard one to start off. Do you remember doing this last year? They used to do it a fair amount in pre-cal, but I'm not sure in AP pre-cal how much they go through. Let me show you real quick. I'm a visual person. I know I've told you that. So I actually kind of like to look at this visually just real quick. If I look at this expression right here and I graph x squared minus 9, that's a quadratic shifted down 9. And then if I just like look at the 0 line, which is this right here, and my expression says anything greater than or equal to 0, then that means this piece of the graph and this piece of the graph satisfy that restriction. And that's why my answer is less than -3 and more than +3. So if you're a visual person and you'd rather graph it, that also works. Like you can visualize the graph and know that this is positive, negative, positive, and just pick the positive ones. Okay, question number 3. I want you guys to try this. I'll work it quietly on the board too, but will you try this one on your own first? Okay, correct answer there was -2 to 2. Are you guys okay with getting that? So you kind of factor first, get your zeros on the number line. At the zeros, we put a closed-in circle because of the equal to. And then you test values within your factors or up there to see if you get positive or negative. It's positive in the middle. Alternative way of solving this is to imagine what the inside looks like, what this quadratic looks like, which is open, down, shifted up 4. And then you take the part that's above the x-axis, which represents greater than 0. Okay, any questions on 3? Okay, the last one of your domain range is both a fraction and a square root combined. Remember I said we gotta look for fractions, square roots, or logarithms. Question, sorry.
We always use the equal to sign for the.
For these, yes, absolutely. Yep, and actually I'm gonna go back up and show you. Okay, it's different this year. Okay, just real quick. This right here, it will always be greater than or equal to for a square root. Now I'm going to show you one exception to that rule, and it's just if the square root is in the denominator of a fraction, because then it uses both those rules at the same time. That's the only time you only put a greater than, which that's what we're about to do. So on this last domain problem, it's a square root and a fraction. So in this case, when I go to take my like square root interior, I normally would do this, right? But because there's 2 like rules to follow on this, it's a fraction and it's a square root, I'm going to delete this. I'm not going to use the equal to because I also don't want to divide by 0. So I could plug a number in this denominator Like this square root could be 0, but then I can't divide by the 0. So instead of having equal to, I just do greater than, and then this math is super simple. I just get x greater than 1. So the different ways you could write your answer would be real numbers greater than 1, x greater than 1, or 1 to infinity. Yes, question.
How do you just like cancel out the radical?
So whenever you're doing square roots, you only take the inside. It's not that we've canceled that out. It's just that we're making sure that whatever number I plug in here gives me something inside the radical sign that's more than 0. And then nope, you don't have to worry about the x. So all you worry about is the denominator of a fraction, the inside of a square root, or if there's a logarithm, which we haven't, we're going to review logarithms another day. We'll do that more in depth another day. Because we just haven't gotten to logarithms yet.
I think square root that,
Why is there what? Why?
would the x ever be squared in the denominator?
Yeah, for sure. It could be. So this could have said that, right? And if it did, then you would just be over here doing your number line like we did before. But your number line would just, sorry. So if it said x squared minus 1, you'd be doing your number line, but with open circles there instead of closed circles. That'd be the only difference. Great questions. Any others? Yes, question. Yes, only because it's in the denominator. So with a denominator, you can't divide by 0. And that's why we took away the equal to 0 part. So it's like, well, we don't actually want it to equal 0 because it's in the denominator. Yep. Okay, last thing I want to show you today real quick is just a little bit of plugging in for functions. And you're going to practice this today also before you go. And there's like 3 or 4 problems on the page that are like this. So just want to make sure we understand how to do it. So first of all, evaluating a function like f of 5 means that I plug 5 in for the x's. So I know this is a completely different topic, but all these things are going to like relate together with Tuesday's notes. So this would be 25 plus 35, which is 60. Okay, fairly straightforward. Then we're going to make it like a little more complex. F of 2a plus 1 means I'm plugging 2a plus 1 in place of the x. So 2a plus 1 squared plus 7 times 2a plus 1. Okay, sidebar for a second. You cannot distribute a squared sign if there's a plus in here. Because of that plus, you have to write what squared is, which is the thing times itself, and then FOIL it like this. So this will be 4a squared plus 2a plus 2a plus 1. Then I can just distribute the 7 and get 14a plus 7. And then combine all the like terms. So 4a squared plus this be 4a plus 14a would be 18a plus 8. And then last, this x plus delta x, this always throws everyone for a loop. So I was kind of like warming up to that when we did the 2a plus x or 2a plus 1. It's 2 different things. So we're going to have to plug it in and FOIL it out. But delta x does not represent 2 different variables. Like it's not like delta is its own thing and x is its own thing. This could just like you could change this to be an h, and you might have done some problems last year in AP pre-calc with x plus h. You didn't know. Okay, so delta x just counts as one single letter. It means the change in x, like you got x and then x moves, like the change in x is just one number. Like this counts as just one letter. So don't treat that as 2 separate pieces. So plug this in, it's going to look like this. X plus delta x squared plus 7 times x plus delta x. Okay, then let me do a little sidebar about the squared thing. Again, if you have a plus sign, you can't distribute this squared into that problem. You have to multiply it by itself. So we do x plus delta x, x plus delta x. Okay, so when I multiply out, I get x squared. Now, when I multiply this by this, again, think of delta x as its own single letter. So it does not, this x and this x can't be combined in any way. Like the x's are just, they're different x's. There's x and delta x. So this would be called x delta x. So I hate that. Yes, question.
Can you just sub out your own variable? and
Yep.
sub out your-
Yep, sure can. So if you'd rather, you can be like, let x or let delta x equal h, and you can change it to an h or whatever letter you want, and then change it back at the end. You sure could. And then here we have another x delta x. And then last, we have delta x squared. Then I ran out of space there, but then I have plus 7x plus 7 delta x. Actually, I don't even, does anything even? Okay, never mind. I was gonna say, nothing combines, I don't think, but actually these two combine because these are the same. So for your final answer, you'd have x squared plus 2x delta x plus delta x squared plus 7x plus 7 delta x. We will work a fair amount with delta x. So I know the first time seeing that, it feels very, very like foreign and weird and awkward to have like two symbols together. But again, that's just like a different letter, so to speak. Okay, so we have only about like 18 minutes left. What I want you to do today for the rest of class. By the way, there's no more delta math over the weekend. Okay, there's delta math next week, but not like there's not delta math for today. Today's assignments are going to be this worksheet, which you might be able to finish before you go, but it's not due until Tuesday. But probably you can finish most of this. Okay? If you finish that, then you're going to continue working on last lesson's worksheet. So like yesterday, you might have picked this up. You would get started on this, but again, this isn't due until Wednesday next week. So this isn't a big rush. This is like bigger priority. If you have extra time, start on yesterday's page. And then if you still have extra time after that, you could work on a WebAssign assignment. So like we pulled up WebAssign yesterday and did those 5 problems on there. If you log in there, there's like a chapter 1 assignment on there, but you could get started on that also. You only could do a few problems from there, but you could do a few of them. I encourage you to make a friend nearby, because Tuesday you pick your seat, so you probably want to have a friend to sit near. Yeah, I think we did this. Also, I think on Tuesday, I think those 2 back seats are probably going to be gone. I think I'll be able to get rid of a couple of desks. So you can get started. You can come work at the whiteboard table if you like. Do show your work on here though. So once you get done with all of our sort of then didn't have a chance to get closer. So like one people, yeah, so if you want to, I don't think they did a lot of things. It's like, you know, you're really having this business. And then you want questions for the future. Yeah. It's.
So this is like. You actually. It's the human. Is he like?
This is ready.
Yeah.